People don't want to hear this anyway. So yeah, we had an interesting thing, right? Where one of my friends, we were playing hockey. He got a stick between his legs and it popped his knee out, right? So he dislocated his knee. So he's lying there. He's on the ice and he's just in a ton of pain. And by the time the paramedics come, it's by the time they get him to the hospital and they get it all put back in, it's like 45 minutes, an hour later. And they're like, listen, if one of you had known how to do this, he probably would have been okay, right? Like if you could have popped his knee back into place, he would have been walking and fine within 20 minutes. Instead, he was out for kind of like 2 months because of the inflammation and everything. But we were just like, okay, that's fine. That's great. There's no way I'm popping this dude's knee back in. Like, I don't know how to do that, right? Like, I don't know how to do that. Yeah, I've done some nasty things in me, right? Because I spent so many times, I spent almost a decade in kitchens. So I just about cut this finger off just because I wasn't paying attention. I was cleaning a knife. Some pretty lady walked in or something and cut right down to the bone here. Another time, so I have a scar here. It's probably not coming across super well, but I'm like, the deli slicers, right? So I'd taken the shield off of it and had to like move it to the side. It was a small one, not like one of the crazy ones in the grocery store. And it had exposed wiring underneath. So when I grabbed it, it actually shocked me. So I dropped it and the blade came down and caught me like this. And luckily it didn't sever these tendons, but it went pretty deep. I've had a couple times where like I'd slipped and fallen onto a grill like this. And so just like toasted this part of my arm. Nothing like too crazy though, right? There were always stories of like guys who'd reach into the sink and grab a knife and just cut all these tendons. So, terrible things like that happening. Oh, why are you running your hand on the edge of the face?
You can call that a casual Tuesday, huh?
That's all right. Right? Just Brandon is just loves touching razor blades for some reason. Yeah, absolutely. All right, we're at 70%, so let's do another 30 seconds or so, and then I'll close this up.
It's also an overwhelming favorite here, so.
Yeah, which is good.
It is good.
Yeah. Okay, so I'm going to kill it. We're at 80%, which isn't too bad. I'm kind of happy with that. Overwhelmingly, we're at C for our answer. And yeah, absolutely C is correct. And I'm actually just going to, I know that the screen got dark for a second, just because I want to copy that so I can paste it into here. Okay, so here are the 4 matrices. Which question is this? I guess I should say which question this is. So I kind of jumped a little bit. I'm going to go back, so don't freak out about it. But this is actually question 8. Right, and remember the question is, which of these matrices is in reduced row echelon form? So let's hit them one at a time and see what we can do. So we're pretty sure C is the correct answer. Most of you identified, this is the correct answer right here, which is great. And if you're not certain about that, please ask a question. But let's go through A, B, and D and see if we can figure out why they're not in RREF. So if we're looking at A right now, can anyone tell me why A is not in reduced row echelon form? Because below the leading one, there's a 2. It should be a 0. Well, yeah, it depends on what you mean by below the leading one. So, and then 2 1s in a column. Sure, yeah, absolutely. There's many 1s. Okay, yeah, so basically this thing. So here are our leading ones. Let's identify our leading ones first. This is a leading 1. This is a leading 1. And this is a leading 1. 2 non-zeros in column 4. Actually, that's okay. So the non-zero elements in column 4 aren't actually an issue because there's no leading 1 in column 4, right? So in reduced row echelon form, if you're a leading 1, you have to be the only non-zero thing in your column. So that says that the bad things, maybe let's use red or a circle, that's the bad thing right there. Okay, that number 1 that's in the red circle or the pink circle, whatever that is, that's the thing that's preventing this from being in reduced row echelon form. Now, interestingly, this kind of worth pointing out, these things, these are okay. Okay, they're allowed to be there to be in RREF because RREF just again says You can't have anything else in a column with a leading one, but there is no leading one in this column. So they are both allowed. They are both allowed to be there. Okay. So as a direct message, does the leading one need to be a one, or can it be any real number? It should be a one. Like if you want to put it into reduced, so this is a direct message. Does it have to be a one? Can it be any other number? To be in reduced row echelon form, it does need to be a one. Now, obviously, when you're doing things like computing rank, it's possible to determine the rank well before you actually get it into RREF. And in those cases, you don't need a leading one. You just need to know that something would become a leading one. But for RREF, you really do want it to be a leading one, right? Just because technically that's what it means. And in particular, RREF, we want to be able to say that it is unique, that given any matrix, if you put it into reduced row echelon form, there's only one reduced row echelon form. If you don't require that number to be a one, it might not be unique anymore, right? So that's kind of the issue that might come up if you don't require it to be a one. Okay. Why are 1, 2 fine in column 4? Because there's no leading one there, right? So again, in RREF, right? Let me just kind of, maybe we'll kind of remind ourselves. So in RREF, a leading one must be the only non-zero thing. The only non-zero element in its column. Okay, so in particular, if a column does not have a leading one, anything is allowed to happen to it, basically, right? So this fourth column here does not have a leading one, so it is okay. It is allowed to have whatever it wants inside of it. Okay, so that's why there's no issues with that 1 and 2 in column 4. Does that make sense? Okay, just like the green rectangles there, those are the leading ones. They have to be by themselves, right? And same sort of thing. If we look at the correct answer, these are the leading ones. You'll notice they are, if you look at their columns, they're the only non-zero things. But this 2 here is okay. Why? Because there is no leading one in its column, right? So there's no leading one here. So it's allowed to be there. Same thing here, right? There's no leading one. Okay. But are these all considered REF? No, A is REF. Okay, so note that A is in REF, but it's not in RREF. Let's do B now. Now, what's wrong with B? No leading one in the last row, exactly. So B is not even in REF, right? Because in REF, you still have to have leading ones. This thing here is not, this is not a 1, right? And this is an issue. So this is not a 1. And that's actually going to prevent us from being even in REF, let alone RREF, right? So this one's not even in REF. Okay. C is good. We know that C is the correct answer. What's wrong with D? It's not staircase. Yeah, perfect. Right. These are our leading ones. So this is not a staircase. Perfect, right? And there's a way that you actually say that, where you say like each leading one must occur to the right of the leading one before it, right? Which is a little bit complicated, but if you think about it, hopefully it'll make sense. And it's this issue right here. If each leading one must occur to the right, must occur to the right of every leading one above it, we see that the third leading one actually occurs to the left of one of the leading ones above it. So it's not in RREF. It's not even in REF. Okay. Brandon, absolutely. If we did flip R2 and R3, then this would be in RREF. So if we flip R2 and R3, then this would be. RREF. Okay, yeah, so exactly. Okay, so Curdy, I don't know if I missed your question or if it was already answered. Which one are you referring to? Why can't the last one be a leading one? Oh, like why can't, here, let me put it in blue. Why can't this one be a leading one? Right, okay. So the leading one has to be the first non-zero element in its row. So if we start in row 3 and we start walking and we say, okay, what's the first non-zero thing we hit? It's that thing, right? It's that one. So that has to be the leading one, right? For it to be a leading one, it has to be the first non-zero thing in its row. And you'll notice that is true as well of all the other leading ones, right? If we start on the left and start walking, then the leading one is the first non-zero thing in its row. And that's what gives us the staircase, right? In Daniel's tutorial earlier, he solved the matrix even if the ones are not in staircase form. He said it's okay since you get the same answer. Okay, yeah, so this is a direct message again. So in Daniel's tutorial earlier, he solved the matrix even if the ones are not in staircase form. He said that it's okay since you'll get the same answer anyway, so does it matter if the one is not in the staircase? That is true. In D, you could solve D. If you were to write D as its linear system and solve it, you would still get the same answer. The reason that we use RREF is one, again, because it's unique, right? So in order for it to be unique, we need to ensure that, I can't flip around 2 rows and get the same thing. So because we want it to be unique, we do demand that that's true. But technically speaking, D is no more complicated than if you switched row 2 and row 3. You would get exactly the same answer, right? Because we know that switching rows is just like moving the equations. And of course, you're going to get the same answer, right? So if all you're asked to do is to solve something, absolutely, by all means, you don't have to put it into RREF. But in this case, we're specifically asking about RREF. So in that case, we do need to make sure that those rows are in the correct order. Okay. All right. Everyone good? Are there any remaining questions?
Excuse me, Professor.
Mm-hmm.
If we multiply half in row 3
Which matrix?
in B,
Yeah.
wouldn't that become RREF?
Yeah, absolutely. Yeah, absolutely. Great point. So if we multiply, I guess I was using red. So 1/2, oh, that's green. 1/2 R3 into R3 would become RREF. Absolutely. And kind of related to that direct message, which was asked, note that you could solve matrix B without putting it into RREF, right? That third equation reads 2x3 plus 2x4 equals 0. In RREF, it would be x3 plus x4 equals 0. And you can see that, yeah, anything which satisfies the first equation is going to satisfy the second one as well, right? So going back to that direct message question, even for B, we could have stopped there and tried to solve the system, and it would have been totally okay, right? RREF really does represent the most simplified system that has the exact same solutions and is also unique. So things are kind of presented in a reasonable order. Okay, so that's the idea there. All right, let's see. Which one did I want to do next? I might want to do question 4. Let me take a look. Oop, too far. Oh, you know what? I want to do this one. And then as a bonus to, well, let you do this one first. And I think we talked a little bit about this sort of thing in the office hours yesterday, but I know not everyone was there. So, but for those of you who were there, hopefully you'll remember this sort of discussion. octave something. I love it. How do we know if the last number? Okay, we're at 2/3, so I'll give you another 30 seconds or so. And test, is it fine if we do row reduction in octave and just explain that? Yes. Yeah, 100%. Just do it in octave and say, draw an arrow and said, row reducing by octave, I got this thing. Okay, 10 seconds or so. Get your answers in if you don't know. All right, so we're leaning towards D, which is awesome because D is absolutely the correct answer. So let's see what's going on here. So this is now question 4. I told you I was going to kind of jump around a little bit. So question 4, and we had this matrix. Oh, sorry, this is question 5 actually. So we had the matrix 1, 0, 0, 0, 2. So very quickly, is this matrix in RREF? Can anyone tell me? Okay. Yeah, okay, let's take a look. The leading ones are these guys right here, right? And they are by themselves in their column, right? They're the only non-zero thing in their column. So this matrix is in RREF. Okay, so how do I know that there's infinitely many solutions? Now, first of all, like I think that we should solve this system just, while we're here so that we get an example of how you would solve this thing for infinitely many solutions. But how do I know just by looking at it, how many solutions this system has? If you had to describe it to me, if I gave this question to you on a test and I said, tell me how many solutions this have, what would you do? Interesting. Okay, so the last row being B being equal to 0 actually doesn't guarantee that you have infinitely many solutions. It turns out, yeah. Repeat the question. So the question is, just by looking at this without doing any math, how do we know how many solutions this have? So we have, Sanam, you said rank times the number of columns. It depends on what you mean there, but like, yes, that's the right idea. Connie, I'm not certain what you're saying. It's infinite because the variables are greater than rank, right? And Agam, right, Agam, you're on the right track as well, which is right, that there's no leading one in column 4, so that guarantees that there will be a parameter. Exactly. So now the way that we say that though, is what Aiden said, which is to say, look, let's look at the rank of this system, right? So what is the rank? Somebody just define for me, what is rank? How would I compute it? Exactly, it's a number of leading ones, right? Number of leading ones in RREF. And since this, you can use either REF or REF, it's the same. And exactly, Ahmed, you're right. This is rank 3, right? Because it has 3 leading ones. Rank is 3. Okay. Now, how many variables? Right, exactly. Yeah, n minus r. We'll see it in a second, Connie. Yeah. And yeah, you're just kind of jumping ahead of me. Yeah, how many variables does this system have? This system has 4 variables, right? Every column is a variable of this system. All right, so it has 4 variables. All right, so each column, let's name the columns. Maybe this is variable 1, column 2 is variable 2, column 3 is variable 3, and then variable 4. So if your rank is less than the number of variables, and you have solutions, right? Remember, the first thing you want to check is that you don't have one of those rows of zeros that has a non-zero thing on the right side of the augmented matrix. But if you know you have solutions, and then the rank of your matrix is less than the number of variables, that means you have infinitely many solutions. Okay, so since the rank is strictly less than the number of variables, I guess that this bracket should really be here. That tells us we have infinitely many solutions. Okay. So if the rank is equal to the number of variables, you have one solution. You have a unique solution. That's the only way unique can happen. Okay, is if the rank and the number of variables are the same. The only other thing that can really happen, other than having no solutions, is that the rank is less than the number of variables, in which case you have infinitely many. Now, Connie, that thing that we were talking about in terms of this n minus r is to say, well, how many parameters does your solution set have? The number of parameters is the number of columns that don't have a leading one. That's the same thing as the number of variables minus the rank, right? N is the number of variables. R is the rank, the number of those columns that have a leading one. So n minus r is the number of parameters. It's the number of columns that don't have a leading one in it, right? So the number of parameters is the number of columns that don't have a leading one which is n minus the rank, or in our case, that's 4 minus 3 equals 1, right? So that's what the n minus r is. Does that make sense? As Agam was kind of saying earlier, x4 is going to be the parameter. And the reason why x4 is the parameter is because there's no leading one in that column. And so how many columns won't have a leading one? It's precisely just the one. Exactly. We have a 1 parameter solution set. Okay. Any questions about that so far? I'm actually going to solve this system because I want you to see where that parameter comes in. And I think, you know, even though I might have done this in the videos, it'll help to do another one. So are there any questions about that before I actually try and solve the system? How do we tell if there's no solutions? Would it be a row like that? Exactly, Brandon, exactly. So there are no solutions if you have one of those rows, because if you had a row that was like 0, 0, 0, 0, 4, if you rewrite this as a system, this would be 0x1 plus 0x2 plus 0x3 plus 0x4 is equal to 4. And this isn't possible, right? Because this is the same thing as saying 0 is equal to 4, right? That can't happen. Now, if you have a row of zeros, including a 0 on the right-hand side, this is okay, right? Because this is that line, that row says 0 is equal to 0. So you don't have any useful information from it. It doesn't tell you anything good, but it doesn't block you from having solutions, right? So if there's a non-zero number where the 4 is, if this number is not 0, then you don't have any solutions. But if it's 0, you don't know anything. It just tells you that there was redundant information in your system. Okay. Rank can never be greater than the number of variables. So Connie, it's a great question, but it turns out that's just not possible, right? Because again, think about it. Like again, we'll have to think about it a little bit, but it is such a great question. Can the rank be bigger than the number of variables? Well, the rank is the number of leading ones. And so the question is, can the number of leading ones ever be more than the number of variables you have? And if you think about just like the way that a leading one has to work, it's actually not possible, right? Like, and because remember, when we look at the rank, we only look at the non-augmented portion, right? We don't look at the part after the equal sign. So it's actually not possible to have the rank be greater than the number of variables, but it's a very interesting question. Yeah, exactly. 0, 0, 0, 4. And of course, the 4 there isn't special, right? It could be any number other than 4, Connie, right? You could have anything else there. But yeah, that's the same sort of thing. If you have a row of zeros in the matrix, the coefficient portion, and then a non-zero thing in the constant column, then yeah, you don't have any solutions. Yeah. Christian, exactly. That row is okay, but useless. Yeah. Okay. So now let's actually solve this system. Okay. So I just want this to be on my screen. So I am just going to kind of copy and paste this down below. Hopefully that worked. And if not, I will just, haha, look at that. All right. So this is the system. Now let's actually solve it. So if you want, you can rewrite it, but you have it on your screen. I just wanted to bring it down here so that I could, so that we can all see it. Okay, so let's solve this. Okay. Now, when you solve a linear system, you actually want to rewrite it as a linear system, right? Don't keep it as an augmented matrix. Turn it back into a linear system. And so we're going to get x1 is equal to 2. x2 minus x4 is equal to 2. x3 plus 2x4 equals 0. Okay, now, again, I did this in office hours on Tuesday, and for those of you who saw it, maybe you'll be bored, maybe not, but let's make sure that everyone sees this and we all get the benefit of it. So again, the idea here, look at the correspondence of the leading ones and the variables, right? When you're in RREF, what you've managed to guarantee is that any variable corresponding to a leading one, the row in which it occurs is the only time it'll show up. Okay, now that was a lot of sentences. So let's think about what this means. So this 1 in the top row corresponds to x1, right? And if you're in RREF, what we're saying is x1 will not appear in any other equations, right? Why? Because the coefficient of x1 in the second equation is 0, and the coefficient of x2 in the third equation is also 0. So the only place that x1 will show up is in the first equation. If we look at the second, maybe let me use a different color here. If we look at this thing, then the only place it will show up is in row 2, right? Because the coefficient of x2 in the first row is 0, and the coefficient of x2 in the third row is 0, right? So does everyone see that? This is the benefit of being in RREF, is that your leading ones only occur in the equation, in one equation, right? And that equation corresponds to the row in which they occur, right? Everyone's okay with that? That makes sense? Okay. Now, the other benefit of this, and you can even see the staircase pattern happen, right? You see the staircase? So the thing that we can do now is you can solve for your leading ones in terms of your variables that aren't leading ones, right? So what we're going to do is let's rewrite this. Well, x1 equals 2. There's nothing to do there. That's already done. x2 is equal to 2 minus x4. And then x3 is equal to negative 2x4, right? So you can solve for your leading ones. These are still your leading ones. You can solve them in terms, oh, you're right, thank you, 2 plus x4. Thank you, everyone. I can solve for my leading one variables in terms of all of my variables that are not leading ones, right? Not leading ones. And so this is where the parameter comes in. So every single one of those variables on the right-hand side, we're going to give a parameter name to, right? We're going to say let x4 be some parameter s, right? Oh, but there's no t this time, right, Curdy? Because there's only one parameter, right? If there was another parameter like an x5 or something, you're right. In that case, we'd probably call it t, and you can call them whatever you want, right? Like you don't, no, it doesn't matter what variable you want. You can call it u or v or happy face or banana, whatever you want. Usually s and t are nice. They're kind of a standard choice for parameters, but that's what you would do. And then when you write out your whole solution, you'd say x1 is equal to 2, x2 is equal to 2 plus x4, but x4 is equal to s. x3 is equal to negative 2s. And then don't forget, when you're writing down the whole solution, you also want to include your parameters in here. Okay, so here's your solution. And if you want to write that as a, like in terms of vectors, you would write this as 2, 2, 0, 0. Oops, this shouldn't be plus, equals plus s times 0, 1, negative 2, 1. Right? Okay. 2 plus x4 plus 5. So if it was like this, we would use two variables. Exactly. Yeah. Okay. And so for those of you too, as well, like when we remember when we were talking about like, oh, why is the parameter the columns that don't have a leading one? This was the x4 column, right? It did not have any leading ones. And the reason for that is we solved for the leading ones in terms of the other ones, the columns that don't have a leading one. So those variables are going to go to the other side of the equation, and they're going to become parameters. Got a direct message. Why is it 2, 2, 0? There isn't an x5, Anaga. That's just, you know, she was having an example of like two parameters. Okay, here, let me, oh yeah, you're right. Yeah, it should not be an x5. I apparently just don't know how to count. X3, X4. And then there's still this question of why is there a 2, 2, 0 column? So maybe let me do this one a little bit slower. So if I write this as a vector, I've got x1, x2, x3, x4. And basically what I want to do is I want to separate the constants from the s's from any other parameters, right? So the constants I want to all have together. And then I want to have the s's together. Maybe let me kind of really draw them spread out to really try and emphasize that. Okay, and now I'm going to split that up. I'm going to write this as 2, 2, 0, 0 plus 0s, negative 2s, s. And then I'm going to factor the s out of that right-hand side there. 2, 2, 0, 0 plus s, 0, 1, negative 2s. Oh, 1. Does that make sense? Okay, perfect. And for those of you, this is remember the last video is about like particular and homogeneous solutions. This is the particular solution, and this is the homogeneous solution. All right. And so this was actually one of the options, right? Did you notice that this was actually an option, that 2, 2, 0, 0. The system has exactly one solution, and it's 2, 2, 0, 0. This is actually a solution to the system, but that question is wrong because it said that there was a unique solution, and actually there were infinitely many. Yeah, and that's it. This is every single solution. Every single solution is of this form. Right? And so if I give you different numbers for s, you could plug them in and you would get a different solution, right? So for example, if s is equal to 4, then we would get this solution. What? We would get 2, 2, 0, 0 plus 4 times 0, 1, negative 2, 1. And if we were to do that, what do we get? We would get 2, 6, negative 8, 4. And you can check, like plug that into the original equation and see that it's a solution, and then change the number 4 to negative 5 or something and plug it in and see that it's a solution. Okay, yeah, I got a great question as a direct message. Sure. And so person who just direct messaged me, yeah, let me talk about that. So there's this great question of what is the difference between the particular and the homogeneous solutions, right? So that's great. Yeah, we can talk about that. Okay, so the particular solution is a solution, right? So for example, just take a second, try and convince yourself. I want you to take this number and I want you to plug it into, no, that's not the right one. Plug it into this, okay? And I want you to convince yourself that that does work, right? If x1 is equal to 2, x2 is equal to 2, x3 is 0, and x4 is 0, that does solve the system. Do you agree? Right? But notice that this is actually not this XH thing is not a solution. What do you get when you plug this? So it's not a solution, but what does the right-hand side become in every single case? Right? So if I plug this, maybe let me say it like this: x1, x2 minus x4, and x3 plus 2, x4. What do I get when I plug that into this? Yeah, it becomes all zeros. Right? Do you all agree that if I were to plug that into that same system, ignoring the constants, the twos, and the zeros, if I plug that in, I get all zeros. Right? What do you mean, can we see it? I'm not. Right? Because it like just, no, I'm not even saying to solve it. I'm just saying like actually try plugging in. So I'm going to plug 0 in for x1, right? X2 and x4 are both 1. So when I subtract them, I get 1, or I get 0. And then if I do x3 plus 2x4, that's -2 plus 2. So that gives me 0, right? Okay, so Ahmed, do you want me to explain the homogeneous part again? Okay, here, maybe let me explain this in a different way. So XH is a solution to the same matrix. Okay, this was the matrix that we had above. 0, 1, 0, -1, 0, 0. But this time, okay, don't write this down. If you're writing this down, don't write this down. So this was the original system that we had, right? It had this 2, 2, and 0. I'm going to get rid of these 2's and replace them with 0's. This is a homogeneous system, right? That's what homogeneous means. It means that the numbers in the constant column are all 0. That's what it means to be homogeneous. And XH is a solution to the same coefficient matrix, but now where you replace all the constants with the number 0. Does that make sense? Right? This rectangle here, this vector is a solution to that system. Okay, and in fact, every scalar multiple of that is a solution to the system. Exactly, Brandon. Exactly. That is a solution to the system if it were homogeneous. And actually, you know what? You should include the S because it works for every single S. Okay, so when we say that we can break a solution, any solution, into its particular solution and the homogeneous, what we're saying is XP satisfies the system with its constants, and XH satisfies the same system, but where all the constants are 0. It depends on what the question is asking you, right? I mean, generally, if you're asked to give the solution set, you should write it like this. There's probably an argument that depending on how you're asked, stopping here would be okay, and even stopping like here would be okay. Those are actually the same, but it usually is good practice to split it into the particular and the homogeneous solutions. That is generally a good idea. Okay, and all you have to do, the particular solution is always the constants, and then the homogeneous solution is factor out the parameters from each of those vectors, and that's what you get. Okay. I'd like to do one more. We're not getting too many done this week. That's okay, because I think think we're doing, actually, which one do I want to do? We just talked about that. All right, let's do this one. Yeah, it can be. It's just something that for sure takes a little bit of practice, right? XH always makes the right side 0. Absolutely, Anaga. Yep, that's exactly the definition of the homogeneous and what it does. That's what it does. Yeah, and I mean, like I said, I'm not too worried about spending time on these questions, because the great thing about these questions is that, so for example, that last question we just did, all I was asking you for is how many solutions does the system have, right? And the answer was infinitely many. But then we tangented and I showed you how to actually solve that system. I don't mind doing that, because let's think about what I got to do when I did that. I got to talk about how you actually solve one of those systems. I got to talk about homogeneous systems. I got to talk about writing things in terms of homogeneous and non-homogeneous systems. We got to talk about rank. We got to talk about like the number of variables. We got to talk about whether the rank could ever be bigger than the number of variables. So that one question, although it by itself was simple, kind of spawned us into 5 or 6 other things. And so I really don't mind spending that time, because we basically are going to talk about those things anyway, if we had done other questions. And so we kind of knock them all off in one go, right? So I am okay with that.
I think a lot of people answered this question too quickly at the beginning, and it kind of skewed the results.
Yeah. Yeah, 73%. I'm going to give you 20 seconds. Get the rest in. Okay. Yeah. All right, class. So most of you said A. A is not correct. But the question becomes, did you get it not correct because you don't know what rank is? Or did you get it not correct because it is B? Yes, it is. Yeah, exactly. You do need to change it to RREF. You could change it to REF instead. Right, that would also give you the same answer. Don't forget though, there's that little 2 there in the bottom right-hand corner, right? So you don't want that little 2 to screw you up. So question 13, we've got this matrix. If I wanted to turn this into RREF, what would I do? So just give me, a couple of row operations that you might want to do. No one? 3R1 minus R2. Okay, sure. Yeah. So 3R1 minus R2 into R2. And yes, but not, that just kind of like is lucky. Yeah. Okay, so Brandon, if we just do Brandon's, I was hoping we could do a multiple, but Brandon is the only one brave enough. So if we do this, we're going to 3R1 minus R2, so we're going to get 0, 0, 0, 0, 0, -2, -2, -6, 4, 0, 0, 0, 0, 0, 0. Okay, what do I do next?
The number in the bottom right is 2, not 0.
Oh, yes, that is true. Thank you. 2R1 plus R3, absolutely. So 2R1 plus R3 into R3. So 1, 1, 3, -2, 0. See, we're going to save me some time if we do them all. I gotta write out the whole thing again. There we go. Okay. Yeah, next. R4 divided by 2 into R4. Yeah, absolutely. And now I really regret not doing this one before 1, 1. Actually, let's do 2 of them. And then after that, what am I going to get? Maybe just let me cheat here and put this one here. Okay, so I'm very close to, at this point you could stop, right? At this point you can see what the rank is. But technically, if I wanted to put this into RREF or REF, what would I need to do? What would the last step be? Not get rid of them. I don't quite want to like, I don't just want to take them out of the matrix, right? The matrix should always sit, yeah, flip sub. So move them to the bottom, or equivalently, what I'm going to do is I could flip row 2 and row 4, right? 1, 1, 3, -2, 0, 0, 0, 0, 0, 1, blah, 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 right? 0, 0, 0, 0, like this. Okay, great. So the rank is the number of leading ones. There are exactly 2 leading ones. So if I do this, I get rank 2, and that was B. Okay. Now, okay, so are there any questions about that? Is there not 3? So I got a direct message asking, is there not 3? Like, is it not ranked 3? Okay. Yeah, absolutely, use octave. So in fact, I'm going to do it right now, which is let's use octave. So you could totally do that. So there's no rights. Exactly. And so Jeremiah, this is a really great point. So thank you for bringing it up. This matrix did not have, it was not augmented, right? It didn't have that vertical line. So in this case, when we consider its rank, we actually consider the rank of the whole matrix, right? Yeah, okay, yeah. So that, Ahmed, is an important point too, which is really be careful. If you are going to use octave, you want to make sure that you plug the right numbers in, right? It's definitely, it's great for you that it can do a lot of work, but it can't double check that you plugged everything in correctly. You kind of have to make sure that you did that yourself, right? But yeah, exactly. And if you get one of those numbers wrong, you'll get a completely different answer. So assuming that I've done this correctly, I think this is the matrix. Let me take my own advice and just double check. 1, 1, 3, -2. Yeah, 3, 3, 9, 6. 2, -2 times that. Yeah, and then, okay. And then to compute the rank, I thought the line in the matrix is optional. No, so they mean very different things, right? So you do want to be careful about that. And I can explain more about that in a second, but let me finish this off first. Oh, I see. Okay, I see, sure. And so if you want to compute the rank of A, That's not right. I plugged something in wrong. What did I do wrong?
Oh, it's -6. No,
Yes.
it's -6. No.
Yeah. See, and then I would have lost a mark there because I plugged the matrix in wrong. There we go. Rank is 2. Thank you. Yeah. Okay. And so isn't that nice that it just like computes the rank for you? And again, if you want, you can actually just compute it like this. You can get the RREF. That's exactly what we got, right? And from there, you can read that it's -2 as well. Okay, so octave, really, really nice, saving us a lot of time and effort here. Okay, so yeah, maybe let's talk very quickly about, it's not that line is optional, okay? That's not what we're saying. So when we talk about a matrix, because eventually what we're going to do is we're going to call this matrix A. If I augment it, that's one thing. If I don't augment it, that's another, okay? So if this line, or how do I want to say this? This is different, right? This is a different thing that I've written down here. This is no longer a matrix. This is an augmented matrix. Those are different things. Okay, and we want to be a little bit careful about that. So this system would not have any solutions. And this is a system, right? This is a system of equations because I've got coefficients and I've got constants. But the matrix above is just a matrix, okay? It doesn't correspond to a system of equations because it doesn't have an augmented portion. So if your matrix is augmented, and I asked you for the rank, you would only look at this part. But if the augmented portion is not there, if that vertical line is not there, then you actually have to consider the matrix by itself. And you might say, well, this is dumb. Why are we doing that? Well, next week, you're going to see that there is a way of writing linear systems down. Does this augmented matrix have rank 1? It does, Curdy. But like the rank doesn't matter because it doesn't have solutions anyway, right? Because of that second row has a row of zeros and then a 1 in it. But you're right, yes, it would have rank 1. Yeah, we're gonna learn either next week or the week after a way of writing a matrix down such that I basically split off the augmented part, right? I basically do this, and then I split off the augmented part. And so it is important to be able to consider matrices and vectors on their own without having an augmented system. All right, so there is a reason for this. It'll make more sense when we talk about matrix equations, but just keep that in mind. Okay, are there any more questions about that? Let's kill that. No, everyone's happy. I don't think I have any more like good questions. We're kind of into the office hours portion here anyway, but yeah, I think now would be a good time. I'm going to take a little break here. I'm going to take a little 5-minute break. Is it okay if I leave? Absolutely. Yeah, and if any of you guys have to study, I mean, by all means, go study, right? Like, absolutely. We're done today. I'm not going to take up any more questions. I'm just going to go into office hours. So if you've got a test to study for, by all means, go do it, right? The only thing that you have to worry about this week is that assignment. And we can talk about that in office hours if you want, but if your test is more pressing, go do that, right? Random question, but is the 5:45 email the final email for WA2? Yes, it is. Yeah. Okay. I'm going to take... but the call cut off for me when you're explaining what happens if the rank is greater than the variable. Okay, sure. So the rank can never be greater than the number of variables. Okay, is basically what it comes down to. Just the rank can, right? So let me, yeah, I can do this before I go. So let's say I have a system for, right here, let me just use like X's. Right? It doesn't matter how big your system is. You can never have more leading ones then you have variables, right? Because what's the best case scenario? What's the most leading ones you could have? Is like that, right? After that, you don't have any more. There are no more leading ones you could possibly have, right? Because if this were a leading one, well, that's just not possible, right? The leading one has to occur to the right of any leading ones that occur above it. So that's not possible for it to be a leading one. So the answer to that is there just can't be a situation in which the rank is bigger than the number of variables. Okay, so does that? No problem. Our office hours recorded? Sure, I can record them. We don't have a class tomorrow. Absolutely not. Davin, can you just copy and paste into the chat for me the whole thing, like what you did for A and what you did for B? Oh, don't use capital letters. Don't use capital RREF. Use little RREF. Okay, so use lowercase letters, not capital. Okay, Davin, so do that and let me know if it worked. The suspense is killing me. It works perfect. Okay, I'm going to take 5 minutes. Aziz, if you hang around.
I'll hang around for while
okay.
you're going.
Cool, thanks.
I'll answer any questions meanwhile.
Sure. I'll be back in 5, everyone, and then I'll answer any questions you have.
Yeah, Jacob, I see you have your hand raised. You can unmute and ask your question.
I just want to make sure about question 1 from the assignment. We don't need to calculate how many of each one we need, right?
Oh, that's a great question. Let me open up the assignment. You gotta bear with me here. I don't have it. I'm not gonna lie to you, I haven't properly looked at the assignment yet, so you're already way ahead of me. So give me a second.
Okay.
Yeah, so I'm just opening up Quarkus right now. Let's see. You're talking about assignment 3, correct?
Yeah.
Perfect. Let me open this up. So for question 1. Yeah, you do not, like it says, you do not need to solve the system of equations, and you do not need to worry about whether you have a unique solution or not. So yeah, you could just kind of give up the final equations more than anything else without solving them.
Okay. And then for question 3, not question 3, question 2, like
yeah.
It's just really, it's just an explanation, right?
I mean, for a question, you have to, well, it's a bit of an explanation. You just have to show like a bit of equation, but a lot of it is explanation because you can't get like a nice number answer for that one.
Okay, but we don't need, do we need to show an example with it too? Or like
no, you don't need to show an example. Just try expanding try expanding the equations here, like for some of them, and show what you mean. Like you put like a bit of like equations, and then just using like V1, V2, V3, or like something like that, and then you show how you explain it.
Can I email you like my answer to it? And you can tell me if I'm on the right track, kind of, or if I should like.
You can email me. Things have to be very, like, it's weird because assignments have to be relatively careful with what I respond, but you can always, definitely email me, or you can put it as well if it's better. You can put it on PIADS as a private question, but you have to make sure it's private.
Okay.
And there's a lot, like myself and all other like TAs/professors will be able to look into it as well and give you like make sure you're on the right track. But please make sure you're on private, because if we don't do it private, it's a problem. So.
Thank you.
No worries. The whole thing with the writing assignment. Can you write a linear system of equations like this? Equations equals constants. You could. It's not really the generalized form. Like it's not recommended because then people think it's like 2 different matrices. When you put, it's like a matrix equals another matrix. So that's usually you don't want to do it like that. If you want to write an augmented matrix, you put that like vertical line, and then you want to put the numbers, the constants on the right hand side. Just because that's kind of what denotes it. When you put like equations equal to constants, a lot of times it looks like what you're doing is you're making a matrix equal to another matrix, right? From like if I don't know what you're doing and I'm just looking at it from a third-party perspective, that's how it looks like. I would like if it's part of the same equation, I would recommend, as I say, putting it like in terms of one like matrix and then within augmented matrix. If you're doing it in terms of variables, if you remember, like when Tyler earlier today did the example with the open parameter, he put like variable x1, x2, x3, x4 equals to, and then a portion as like a constant plus s times something. That's fine because he's taking each variable is equal to that thing over there. But so that's an applicable use case. But if you're doing it more of in a sense of like just equations, like kind of like splitting an augmented matrix, I wouldn't recommend it. I had written like that before, so I'm just. Yeah, no, it depends on like it's very like yeah. So again, going back to it, it's very dependent. Like I just read your second half message, Curtis. So it's very dependent on what you mean by your equation. So when you put the equal to, that means everything on the right hand side equals to the left hand side, and it's just for augmented matrices specifically, we usually always want to use the vertical line there.
Okay, I am back. Anything exciting happen?
Nope, just some questions about assignment 3 for the most
Cool.
part. Yes, I can. So the question was, can you split up, if you look above, the question was, can you write the system of linear equations with like a matrix with equations equals to the constant alone? And the reason you don't want to write it like that is because if you do, it makes it look like you have a matrix equal to another matrix. Well, in reality, it's not like that. It's mainly it's like the matrix equal to just a constant, and that's why we usually use that vertical line to show the augmented matrix. The only time we usually see a split like that is when we're making like specific variables equal to a specific point. So like when we saw the example earlier that Tyler did in class with the open parameters, he put x1, x2, x3, x4 equals to some constant plus s times some constant. And if you actually rewrite that equation, you can write them in terms of full equations over there. So when you're just trying to find variables, you can put them separately. But when you're it's just an augmented matrix, you can't just separate like that line and make them two different matrices.
Yeah, and I mean, well, yeah, let me, because I think the question is ambiguous enough that let's be sure it's clear. Like if you wrote something like x1 plus x2, 3x1 minus 4x2 equals 7, 5, that is okay, right? Like you are allowed to do this. Don't do this. Right?
Yeah,
you can't do
exactly.
Yeah, you can't do this. This is bad.
That's what I was talking about. That
yeah.
case.
Because in one case you have a matrix like a 2x2 matrix equal to a 2x1 matrix, and that's not allowed. But if you do this top thing, that is okay. Yeah, I don't think there's anything wrong with that.
Yeah, that's when it was saying when the variables are there in the question, like the x1, x2 there, that's when we saw the split, especially when we do a case of the parameters. Mm-hmm. But when it's just the matrix itself with the augmented part, you can't just split them up because then it doesn't work.
Exactly. Yeah, and kind of like going to something similar is like we could split this up as being like, x1 times 1, 3 plus x2 times 1, -4 as well, right? Like we could do that. So Ariana, it depends on what you mean. Like what form is not a linear system of equations? So I would argue that neither of these, like even this, oh, I hit my pen and now it's not working. Uh-oh. So that first thing even is not, it's true, it's not a linear system of equations, but it is equivalent to a linear system of equations. But I think at that point, we're just kind of getting like a little pedantic on what we mean by that. But you're right, technically speaking, that is not a linear system of equations. It is a vector equation whose solution is equivalent to a linear system of equations. But like I said, we're just kind of getting a little pedantic when we say that. So I don't want that to confuse you.
I think Brandon has his hand raised. He has some question here.
Okay, sure, Brandon, what's up?
Hi, Professor. I had a question regarding assignment 3. The thing that I'm having a problem with is that, and I'm not saying this is like a bragging thing to anyone else on the call. It's just, it feels easy, not in the sense that, oh, the questions are easy, but I feel like I'm missing something. So just for my own clarification, for question 1, we're just finding the linear system of equations and we're not trying to solve it or finding the variables or anything.
Correct.
And for question 2, for each part, we're just finding the augmented matrix that would correspond to that linear system.
Yeah, because the coverage for that assignment stopped last week, right?
Oh, okay.
Yeah,
I
and that-
thought it
exactly.
included the week before. Like
Well, the
this
week before was finance. No, yeah, it doesn't
Yeah,
include this.
like when we were doing all the solving and stuff.
No, I always cut like when an assignment goes live, the cutoff for the assignment's content is the week in which it is published.
All right. Yeah. Because
Yeah.
I was having a talk with someone in my tutorial about it. And we just both felt it. We didn't give answers or anything, don't worry, but we were just like, this feels
I mean, if you
too
give
easy.
answers, I don't care, right? The point of the exercise was to get you to set it up. And if you do the extra work, that's okay. But yeah, the whole idea is that I didn't want you trying to solve this, given that it's due the week that you learn how to do those things, right?
Okay.
So that's why we did the cutoff of just set up the system, right? And then the next assignment was actually a writing assignment, but the next assignment will have more of this sort of solving stuff going on in it.
Okay. All right. That makes more sense. Thank you so much.
No problem. When you don't split it, it is a linear system of equations. So even like, depending on what you mean by don't split it, even this, what do I want? 113 negative 4 7 5 is not a linear system of equations. What it is an augmented matrix which represents a linear system of equations, right? And again, I mean, it feels pedantic to say these things because they are all equivalent, and I do want you to be able to fluidly move between them, but they are different things, right? This is an augmented matrix. A linear system of equations is, you know, this. And even though they're used to represent the same thing, they are different, right? They have different types, right? If I wrote that on your assignment, no, if you wrote this is totally fine. Just leave. I think that's probably okay. Like I really just, no, you know what? I would write this out. I do want to see that you can actually write it in that form, Curdy. I would suggest that you actually write that out, right? How much explanation do we need if it's just that? It depends on what you mean, Victoria. Like, because I wanted you to set it up, you should, you know, define variables, tell me how you create a linear combination or how you set up the linear system. And because think about like what you would do in a test, right? So the sort of question you might see in a test is, here is a word problem, set up the linear system of equations and solve it. But solving the linear system of equations is just going to be plugging it into Octave 9 times out of 10. So the majority of your explanation is in setting up the linear system. So you do want to make sure that you're very clear when you provide an explanation about how to actually set the system up. And Dodd, yeah, does that actually answer your question? This is a linear system.
I got a question in the private chat, I guess more regarding explanations about the assignment for
Okay.
question 2. They're asking for question 2, do we need to find the linear system before the augmented matrix, or can they just jump promptly into the augmented matrix right away?
I think you should set it.
Yeah, I agree with you. I think I would personally set up the linear system before jumping into the augmented matrix.
Yeah. Like, and the point of this is to get you to the point where you can jump into it, like, and you're comfortable with it, and you can sanity check your answer, right? Even on a test, though, you should still set it up and do your explanation. But if you just see immediately how to go from a linear combination problem to the augmented matrix, that's phenomenal. And that is the skill that I'm trying to train in you, that you just see, how do I jump between a linear combination problem and an augmented matrix, right? That's the skill I'm trying to train. It doesn't mean that you're not allowed to, or that you can get away with not explaining it, but that's the skill I'm trying to train in you. Right? So these are 3 different things that I've circled here. One is a vector equation, one is an augmented matrix, one is a linear system. All 3 represent the same thing, and solving one is equivalent to solving either of the other 2, but they are technically different things. And we are going to learn at least one other way as well of writing a linear system down. And again, one of my objectives for you is that you can move between all of these very fluidly. Going back to parameters, if there are 2 of them, we assign them 2 different variables. Yeah, absolutely. Yeah, so if there are 2 parameters, give them different names. If you give them the same name, you're going to get all sort of like wacky solutions. So you don't want to do that. So give them different names.
S and T, those are the usual ones.
But I mean, like if you want to, you could even call them S1 and S2, right? Especially if you've got like a bunch of them and you don't want to write them all down. U and V are very common names. Alpha and beta are common names, just, you know, things like this. For 2A, I solved the augmented matrix and then showed the corresponding linear system of equations. Is that okay? I mean, yeah, you didn't have to, oh, you solved for it. You mean you found the augmented matrix and then showed, yeah, that's fine, Curdy. That's totally okay. Yeah, that's okay. I don't think it's an issue. I just, again, I want you to be able to move around these things. And if you basically combined all three of them, that's phenomenal. I have no problem with that. Yeah, as long as you get to that system of equations at the end. And then same thing in reverse too. I also actually want you to be able to do this in reverse. Given a linear system, can you write it as a linear combination problem? So if you're able to move between these, I don't care how you do it, as long as you get to the place you need to get to.
We have another raised hand here.
Okay.
Corporate.
Yeah, I just want to ask, so for assignment 3, like the first question,
Yeah.
I didn't necessarily like put it into like a linear system at first. I just went straight to augmented, but like I still like explained how I got there. I just didn't like go like, oh, x1 plus x2 equals this, and then 3x1 minus 4x2 equals this. I didn't do things like that. I just went
Okay.
straight to the augmented. So would that be okay, or should I just say?
Okay, here's
again.
Yeah, here's my warning about this. In my experience in the past, there are students who have done this because they thought that they put it into the augmented matrix correctly, and they actually put it in incorrectly because they didn't set it up. They just assumed that they could see what the augmented matrix was going to be, and they did it wrong as a result. And then if you provide no explanation as well, then you basically end up getting a 0 on the whole thing, right? So I think it's probably safer to set it up, because then for sure you also know that you got it correctly versus just kind of jumping to augmented. Even if you think you see how it works, it is often better to go through that explanation and make sure that you actually do have the correct thing, right? Like I said, lots of students actually end up writing down the wrong augmented matrix because they go straight to it.
I would recommend, generally speaking, for anything for these type of questions, is do both. I know it's an extra step, it might seem annoying, but as Tyler said, it helps a lot, especially if you get it wrong for poor marks. So it takes an extra like minute, but it saves you potentially a lot of extra marks down the line.
And that extra minute will also, one, you're practicing writing and you're practicing explanation, which is useful when you get to a test. You're perhaps, diving into it a little bit deeper. Like you're really constructing things and explaining it and putting it together. One of the reasons why I also want you to explain, not only because technical communication is important, even if you never go and do math, right? Just technical communication, it is important. But one of the main benefits is that when you have to explain in detail and organize your information, it often, one, points out to you where you're weak. So there are lots of students who don't realize the places that they're weak in until they try and explain something. And they're like, oh, I didn't understand this concept very well. And then being forced to organize that information actually reinforces it in your brain. So this is one of the things that I want you to do as well, is by virtue of explaining, actually gain a deeper understanding of what it is that you're trying to do. There's this famous thing, and I think Curdy might have brought it up way back in the day when we were talking about the rubber duck key to problem solving. And if you didn't read that wiki article, basically what it is you keep a rubber duck on your desk, and when you're stuck on a problem, you try and explain the problem to the rubber duck. And by virtue of having organized the information in your brain in a sufficient way that you can explain it to the rubber duck, you have actually figured out what the problem is, right? So we used to do this all the time. We wouldn't do it with rubber ducks. We'd do it with other students. So when you're trying to explain your problem to another student, it often organizes the information in such a way that lets you solve the problem. So by the time you're done explaining the problem, you know what the answer is. So that is another good reason to explain your work, is it helps organize information. Is it better if we write it in all different ways? Yeah, I wouldn't. I mean, there's nothing, it doesn't hurt. I wouldn't worry too much about it, though. I mean, if the assignment asks you to do something, you can just do that. For the writing assignment, can we use octave? Yes. And I think Aziz answered that.
I answered all the rest of the questions.
Okay, cool. Yeah. Okay, anyone else? A linear combination problem. Yeah, sure. Let me think. Linear combination problem, eh? Try and set something up that's like not just obviously something that we've done before.
Can we maybe do it like the assignment, both numbers?
Like question 2.2 sort of thing?
Yeah, because I get a little bit confused when it comes to like the I's and the M's and using
Okay.
variables.
Sure. So yeah, okay. Let's do something like this.
The one
And I
thing
mean,
about one thing about question 2.2, a lot of people ask me if the numbers above were exponents, and they're not exponents.
yeah,
Like
they're just indices.
they're indices, yeah. So just a heads up there.
All right, I'm just going to make up some vectors. 1, 0, 1, 0, 1. Right. Yeah, let's do negative primes. -1, negative. I mean, 1's not a prime. Also, I missed 2. -5, -7. And let's do V4. Well, I'll stop at V4. Okay, and now I'll make up a fourth number in general. Let's maybe do powers of 2. Let's start with 1. 1, 2, 4, 8, 16. Right? So is B a linear combo of V1 through V4? Okay. So to do this, right, what does it mean to be a linear combo? It means that you are looking to find if there's some scalars that you can multiply each of V1, V2, V3, V4 in order to get B, right? So the question is, can we find what do I want to call them? Let's call them X1, X2, X3, X4, just real numbers, not vectors or anything, just real numbers, such that X1 V1 plus X2 V2 plus X3 V3 plus X4 V4 equals B. And I know that none of you will ever do this, but by the way, if you wanted to make your life a little bit easier, you could do that, right? Okay, and if I actually now write this out, I would get X1. Oh man, I don't remember what my vectors are. 1, 2, 3, 4, 5 plus X2, 1, 0, 1, 0, 1 plus X3, -1, -2, -3, -5, -7 plus X4, -1, 1, -1, 1, -1 is equal to 1, 2, 4, 8, 16. Right? And then if you wrote that as a linear system of equations, or rather if you combine them as vectors, right, you get like X1 plus X2 minus X3 minus X4, 2X1 minus 3X3 plus X4, 3X1 plus X2 minus 3. Oh, this should be minus 2X3.
Oh, I was gonna say it's gonna be -2 here.
Yeah, and then minus X4, 4X1 plus nothing X2, right, because I'm in the fourth row, minus 5X3 plus X4, and then 5X1 plus X2 minus 7X3 minus X4 equal to 1, 2, 4, 8, 16. Right, and you can see what the linear system is. So if you wanted to write this, you know, as not a linear, or as a linear system, not as a vector equation, I'm going to be a little bit lazy here because I've got the power of computer. So as a linear system, that would be damn it. Or as an augmented matrix, it'd be 1, 1, -1, -1, 2. Let's do it like this. This is easier. -1, -2, -3, -5, -7. Like so. Right? And so these are all equivalent, right? Here are the three things. Here again is the vector equation.
No.
Here's a linear system. Here's an augmented matrix. So you got the, oh, so you're just saying you did it. Oh, I see. Yeah, sure. I mean, I don't think you had to, Brandon, go through the augmented matrix, but if you wanted to, sure. Yeah. Right. And then for 2.2, everyone, all you're going to do is basically here, without doing it exactly, I'm going to be like, oh, this is actually A, B, C, D, and E. And then everywhere I'm going to change that to, you know, A, B, C, D, and E.
Well, that's
Right.
can we use decimals for fractions?
Yeah, you could, I guess. Like if you wanted to write 0.007 as 7 1,000ths instead, that's fine.
Oh, we're talking.
A, B, C, D, and E here are just numbers in the vector, right? Like, so I'm avoiding using the same notation because part of what I want you to do is to figure out how to use the notation. But that's just an example of like, oh, instead of using numbers, we're using like abstract letters.
Well, I think Jacob has his hand raised here. I think
Okay.
Can you explain what B and RM kind of means? Like, I kind of know what it means. But I'm still a little bit confused.
By what?
B is the solution vector, or like the solution, and RM is just the real
Oh, I
number
see,
in
I
the
see.
nth,
One,
in
right?
the nth dimension. So depending on how many rows, depending on how many columns you have, that's the number of number of dimensions we have in this case.
Yeah, you can think of RM as being the set of all n by 1 column vectors.
Is it okay if you use numbers for that too?
In 2.2,
No, like just in general, how it would look like. Like, how would it look using numbers?
Any column in a matrix is basically like an R4 basically means it has 4 columns.
Oh, okay.
or 4 rows.
Sorry, 4.
Does that make
Yeah,
sense?
sorry. Yeah, sorry, 4 rows.
Okay. Yeah, that makes sense now. Thank you.
No problem. Curdy by forms, I think they meant like these 3 forms.
We have another hand raised here.
Sure.
Roberto.
I was want to ask, so when you're making like an augmented matrix, you don't have to have any like variables on the right side, right? Like that right side is always constant.
Like on the right side of the augmented matrix.
Yeah.
Yeah, that always means the constants. That's what separates the coefficients and the variables from the constants.
All right. Thank you.
No problem. And Brandon, yep, that's a great way of thinking about it.
I remember Tyler, we're talking about this last year. Actually, I don't know where we ended up with saying, like, this matrix that you're looking at right now with the augmented matrix. Does that count as it has 4 columns or 5 columns? The one you pointed at the bottom right.
Yeah,
I know we had a bit of a debate about this last year.
I don't think it has either. I think it has 4 + 1 columns.
Oh, okay, that's what we came up with at the end.
I mean, like, Yeah, this is a little bit ambiguous. The reality is that augmented matrices are the way that you actually solve things. That's why we show them to you, is that like in terms of actually solving linear systems, everyone uses an augmented matrix. But the reality is that they're basically the worst representation theoretically of a linear system.
Mhm.
So the way I would specifically, if I were talking about an augmented matrix, I would say an n+1 augmented matrix. I would specifically say augmented. And then
Okay.
the n+1 tells you for sure that I'm saying that +1 is the extra term.
Okay, I see what you're saying. Because
Yeah.
I always I get this question a lot of times, and it's always a weird one. Because I always try to say like it's technically 4 columns, but the fit like the last one is just the augmentation is the constant, so it's not really a variable involved. So
Mhm. And
guess-
there's ambiguity, right? Because if I say it's an augmented matrix with 4 columns, do I mean that there's 3 variables and a constant, or do I mean that there's 4
Yes.
variables and a constant, right?
I
So
agree.
yeah, so I think saying 4 + 1 is very clear, right? There's no ambiguity whatsoever.
That's fair, but it's not like I guess common practice. There's no one right answer. Like if I ask just a regular, and it's because I know if I remember talking to some people that were teaching linear algebra a few years ago, and they were adamant that, for example, this bottom right matrix is actually a 4-column matrix and not a 5-column matrix.
So
Or
yeah,
focus.
I think that this conversation just ends up kind of being silly in the sense that
Very much so.
you generally shouldn't be talking, or you should be very clear that an augmented matrix consists of 2 parts. It consists of the coefficient portion and the constant portion.
Mhm.
And then if you're going to talk about an augmented matrix, you shouldn't be talking about its columns. You should be talking about either the coefficient portion, the constant portion, or like basically my question would be, what is the context in which you actually need to discuss the number of columns of an augmented matrix, where saying the number of variables is not better?
That's fair. That's very fair, actually.
Right. And so in that case as well, and it's true, this is an issue for anyone who teaches linear algebra. And I say in that case, it's easier just to not use that language, right? And to talk
Terminology, yeah,
about,
the terminology is kind of tricky there, so that's
Yeah.
fair.
4 + 1 reminds me of complex. Yeah, I mean, like it's in the sense that it kind of is, right? Because when we use complex, we like the real and imaginary part, and we're kind of keeping them separate. Yeah, and here I'm kind of doing the same thing. Like instead of writing a 4 + 1 column, I could write like something like 4, 1 column, right? So you could imagine like a 4, 2 column matrix might have 1, 2, 3. Oh, that's a bad thing, but it'd be
Yeah.
like column 1, column 2, column 3, column 4, augment, and then augmented column 1, augmented column 2, and yeah, in some sense, you're like saying that there's 2 pieces of information here, and I really do want to keep them separate. Like I could combine them and say that this is like a crazy 6-column matrix or something, but I really do want to separate them and keep them separate.
When we're doing inverses of matrices, we have like multiple columns on either end as well.
Yeah,
The
yeah.
augmented.
Exactly. There are these like super augmented columns where you actually add more columns at the end. And in fact, I don't know if any of you have caught on yet, but it would be pretty slick if you did. There are times right now when you all might want to use augmented matrix with multiple columns. And it'd be cool to see if any of you have figured out what the case is yet.
Mhm.
I actually should have done that as an assignment question, but maybe I'll do it later. Yeah.
That's just giving them more things to think about next
Yeah.
time around.
Yeah. So I have a direct message. Tyler, I didn't queue to, okay, it's probably direct because we don't want to say too much of it out loud because it's an assignment question. Yes, Connie, though I'm a little bit worried, and it could just be because you put it to me in a text, but there should either be variables or not be an equal sign. Do you know what I'm saying? Like you're doing the right thing, but you've kind of did what, yeah, okay, by the equal sign vertical line, yeah, absolutely. Yeah, that is what the question is asking you. Brandon, didn't I put that in a video? I think I did. And precisely the reason is that you might want to solve the same coefficients with different constants. And the point is that the steps that you use to row reduce the coefficient matrix have nothing to do with the constants whatsoever. So if there's multiple solutions that you want to compute the answer to, do a super augmented matrix, put all of them, those constants to the right, and then row reduce the coefficients. And what you'll be left over with on the right-hand side is all of the solutions.
A set of solutions. That's actually really smart as well.
Well, that's actually what you're doing when you invert a matrix, right? Because
Yep.
basically you're saying, here's the first standard base, like, right, whatever A inverse satisfies, it satisfies that the first column of B1 has to map to E1, and the second column of
column,
E,
yeah. Oh,
right?
That makes sense.
Or I guess of A, we should call it, right? And so you're actually, when you do this, you're actually solving all n of those systems simultaneously. So that's actually why you do it there.
Yeah, no,
But
I don't think I ever thought of it like out loud. Like this.
Almost no one does. Yeah,
Very,
even
very insightful actually. I've
Yeah.
always just kind of just done it systematically, and I know what it meant, but just never kind of connected the dots like that.
most instructors don't realize that they can do that either. It's like, and it's funny because they see this and they'll teach this, but they don't like remember why they do that.
Yeah, I could see that because I taught linear algebra for like 3 or 4 times, and I just never thought of it like that. Like just, I'm just like, that's the process, and it makes sense, and I know what I'm doing. I know I could do that separately, but I just didn't connect the 2 dots together. Then. Cool, very cool.
Yeah, and again, right, it comes down to this cool fact of that, like, if you realize every time you put, I mean, like, I feel like students would get to it naturally if we said, solve this system, and here are 5 different constants, right? Solve this system. And they'd be like, well, I'm doing the same, after like doing this 3 or 4 times, they'd be like, I'm using the same row operations every single time, right? Is there a way that I can do this faster? And then maybe people would arrive at it on their own.
I think that's exactly that. I think once you see the same raw operations the 3rd time around, I think there's something that clicks in your head. They're like, okay.
Exactly. And that's what I would have done as the assignment question, right? I would have said, here are like 4 different constants, do it and see if you can come up with a clever way of doing it so that you don't have to.
Okay, I get what you're saying now.
Yeah.
It's all clicked in my head at this point.
Okay, anything else? Because I mean, we can totally end office hours, especially if you guys have a test, right? It's because I assume pretty much everyone's taking eco.
I would guess so. Everyone in management and commerce takes econ, so yeah.
I mean, there could be a couple of students here who are taking this course again, or who didn't do 135, 136 very well and are taking 133 now.
Oh, I think Jacob raises his hand right now.
Yeah, Jacob, what's up?
Is there any sort of way you would recommend studying math specifically? Because what I find whenever writing assignments or tests, I get lost using the formulas unless I write all of them out and start matching them together.
Right. Okay. So you're kind of like brute forcing it. Yeah, it seems to be what you're saying, right?
Yeah.
I can answer that for you here because I don't know. At least from my perspective, this is how I would do it. Tyler, you can add on later if you have anything else. But
sure.
For me, at least I know for Tyler's courses specifically, he tests you more on understanding than on formulas necessarily. And this was very evident on your last term test because your last term test had none of the formulas on that term test were formulas you guys had pretty much like verbatim in your textbook. It was like kind of reiterations of the formula, if that makes sense. You have to kind of derive some of them, figure them out. So in my opinion, at least the best way of like learning for math in general and this course specifically is to understand the material. When I say understand, I mean there's difference between understanding and being able to solve this. A big disconnect between the two. Understanding the material, understanding the formulas and what they really mean. And if I was myself in terms of practice, what I would do is I would personally write my own questions in a way where there's curveballs attached and see if I can solve them on my own. Like, let's say for example, like in the case of financial masters, we're done that unit. Like Tyler did, like instead of giving 1 interest rate, do 2 interest rates, do interest rate in alternating periods, do interest rates in like a specific month of the year, like make your own schedule and see if you can answer the questions accordingly. If once you do that, once you start setting up the first few lines and you can understand the logic and put everything together, and you actually know what's happening, that means you're probably doing well in the subject. And if these curveballs are not like you're not clicking with you, that means you probably have some still misunderstanding about the fundamentals of how the formulas work, and you probably have just been learning the formulas directly, which is not necessarily the best strategy. So moving forward, what I would do is whenever there's formulas and stuff like that, try to understand how they come in, how we can actually use them, how we can attach curveballs to them, how we can actually potentially solve those. And if you can able to do all that, I think you'll be good in this course and in math in general, to be honest speaking. But yeah, this course as well.
Yeah, no, I think that's great advice. And not even just like curveballs either, but just always asking what happens if I change this.
Yeah.
Right. Like, there were some students who even, earlier asked, is there a case where rank could be bigger than the number of variables? And just asking a question like that is great because it leads to you thinking about the question deeper and you understand. And if you're able to answer that question, you'll get to a better understanding. What happens if I, not only change one of these numbers in a constant or a coefficient, let's say for linear algebra, what could happen if I add another vector to a linear combination question? Or what happens if I'm in a dimension higher, right? Instead of having a column vector with 7 rows, what happens if I have 8? And so just constantly be asking yourself, well, what happens if I change this? And can I still answer the question? And then try and answer that question. And if you can do that for every possible change that you can think of, then you're in a great position, right? Like you have pushed yourself to a position where you understand really, really well. If you can't answer a question, then that's a great time to ask on Piazza or office hours, because some of those questions, once you change something, they're just not solvable anymore. And you might not know that, but I do and can tell you the answer. But yeah, just constantly take the things that we give you and just like constantly be tweaking them a little bit and then try and solve them again and make sure that you understand, how you got that solution. Yeah.
There's one thing that I did notice with some of the tests and assignments. The similar questions that are on the PDF version with the questions, they're missing in the answer sheet.
Sure, that's true.
Really?
Yeah, there are not every question in the PDF has an answer in the answer sheet. Most of them do, actually. I think especially as you get later into the course, it's more and more and more. But yes, not every single one of them does. Because solutions are dangerous. You're not going to have solutions during a test, right?
Yeah.
You need to practice being able to solve questions without having access to a solution. There are times when solutions are valuable. Don't get me wrong. I'm not saying that solutions are useless, but I'm saying you can't lean heavily on solutions. So there are answers so that when you want to practice and verify that what you're doing is correct, you're able to do that. But then there's also questions that don't have solutions that you can practice answering questions that you don't have the answer to. Because again, in a test environment, you're not going to have solutions. And so you need to practice solving questions without being able to look up the answer. Right?
Yeah.
Because this is and Gerber tab, I see your question, but this is something that legitimately a lot of students do, which is to say, when they study, they have the solution manual open in front of them or the answers in front of them. And, test writing is a skill. And the more you practice it, the better you'll get. So what you want to do is, once you feel comfortable that you understand the material of the course, or at least well enough that you can kind of start doing questions independently of a solution manual, you should start. And you should start trying to do questions and not look up solutions. Even if they have answers or solutions, try to not look at them because you want to practice being able to get over that hill on your own, right? A lot of students, as soon as they hit a wall, right, they'll be like, oh yeah, I thought about this for like 5 minutes. I didn't get anywhere. And then they give up and look at the solutions. But that doesn't do you any good because if you get to that wall on a test and you haven't practiced getting over that wall on your own, then you're not going to get over it, right? So you have to practice climbing that wall sometimes. And in my experience, students are too tempted to look at answers. And so if you give them the answers to every single question, they never practice getting over that wall on their own. So that's why there are a lot, but not all of them.
Okay. If you can go over, doesn't have to be now, but at some point, matrix and row reducing combined?
Sure. So what you should do is try and get an actual question.
Yeah, I have one that I'm looking at right now, actually.
Okay, sweet. Let me try and answer these questions and I'll try and because now there's a bit of a backlog, but then I'll try and do it.
Okay.
So for the writing assignment last time, I didn't have a partner, so I didn't have to give feedback and I didn't receive any. Is there any way I could see an example on how to give feedback? Absolutely. Yeah, Gurpratep, that's a great question. There is, if you check the writing assignment instructions, and it's easy to answer this, right? Oh yeah, no, because it was a direct message to me. If you check the writing assignment instructions, there is a thing there on how to give feedback and what good feedback looks like. And in fact, if you want someone to look over your feedback, you can post it to Piazza privately, of course. And, I'll probably take a look at it and we can give you some feedback on your feedback, right? It's feedbackception. So yeah, absolutely, we can do that. Okay, sure. So Jacob, was it? Do you have the question? The row reduction?
Yeah.
Okay, which question is it?
Suppose, oh, do you want the actual question? Or should I just read it to you?
I mean, if you have the number, I can probably pull it up faster than
It's PDF,
Yeah.
page 70.
70A. Oops, what did I just do? Okay. Sure. So which does it have like a particular example number or anything?
It's example 3.5.
Okay.
Suppose that A is equal to -1.
Oh yeah, and then there's a bit of row reduction there at the end.
Yeah, that's where I get confused.
Okay, sure. So let me see here. Oops. Let me see here. What do we got? So we have, why is my pen not working again? Damn it. Just give me a second here. Get my pen fixed. I think I need to go buy a new pen. They're so expensive. Okay.
It's like nothing beats the good old like blackboards and some chalk, you know? Like
Yeah, 100%. Which is why like I tend to do that even when I teach in person. I definitely prefer it. Okay. So you're comfortable with how we get the augmented matrix?
Yeah, that part makes sense to me.
Okay. So our goal is to turn this into REF or RREF, right? Now there's a bunch of different ways that you could do this. Let me actually do it differently than how I did it in the notes. Okay. So the first thing I'm going to do is I'm going to look like once you've row reduced to a certain point, you're kind of going to not try and reduce the rows that you've done so far. But when you're first starting, usually you start at the top row and you say, okay, the first non-zero thing I hit, that's going to be my leading one, my first leading one. Okay. So I want this thing to become a leading one. The problem is that right now it's a 2. So I'm going to turn it into a 1. And the way that I'm going to do that is just by dividing everything in row 1 by half, or multiplying it by half. 1, 1, 2, 2, negative 2, negative 12. Do you agree? That works? Yeah, okay. Nice, Curdy. I can see you're on the thing. Okay, so this is my leading one here. Now, to be an REF, sorry?
Again.
Can
In
I
the
do
1
what?
over 2 R1.
Yeah,
That
so
1 over 2.
I think our delay in Zoom is screwing us up. Okay, so, or here, maybe let me write this as like R1 divided by 2, right? So I'm going to take every element in here, divide it by 2, and then put the answer back into row 1, right? So if I divide 2 by 2, I get 1, 2 by 2, I get 1, 4 divided by 2 is 2.
Ah, gotcha.
Yeah, so just everything in that row is divided by 2 here.
So,
Okay.
what else?
Okay, so you're good?
Yeah.
Okay, so now that I have my leading one here, I want to get rid of this 2, okay? So to be an REF, everything beneath the leading ones has to be a 0. Does that make sense?
Yeah.
So I want to turn this 2, I want to convert it into a 0. So what I want to do is I want to figure out what should I multiply the first row by so that when I add it to the second row, I get a 0 in that position. All right. So what should I multiply this? And don't even worry about the whole row. Just worry about these two numbers. What should I multiply 1 by such that when I add it to 2, I get 0?
-2.
-2, exactly. So let's do -2 times row 1 plus row 2 and put it in row 2, right? So I'm going to get 1, 1, 2. Okay, so -2 times the first row into the second row, that was designed to make this number 0. Now, if I do -2 times this thing and add it to this thing, I get what? -4, I think.
Yeah.
And then -2 times 2 is -4. And if I add it to -12, I think I get -16, like that. Okay.
And the next step would just be multiplying 1 by 4. Get rid of the -4.
Yeah, exactly. So divided by -4, right? So the idea here is that once everything under my leading one is 0, I now go to the next row and I say, okay, I need a new leading one. This is going to be my new leading one, right? So I'm going to divide everything in row 2 by -4, which gives me 1, 1, 2, 0, 1, 4, like that. Okay, good. Makes sense?
Yeah.
So now we're in REF, right? Now I'm done. So once you've done this to all of the rows, and if there were 3 rows, we'd have to do more steps because there's only 2 rows, we're already done. So once you get to the bottom row, you're finished, right? And now you're in REF, but we're not in RREF yet, right? We need, if we want reduced row echelon form, there's a bit more we have to do. So once we're in reduced row echelon form, you're going to start at the bottom row, and now you want to kill all the numbers above the leading ones as well, because that's what it means to be in reduced row echelon. Not only are the numbers beneath the leading ones zeros, but the numbers above the leading ones are also zeros. So what should I do? What times row 2 should I add to row 1 to make this number a 0? Right? And just look at this number. So what do I multiply this number by so that when I add it to that number, I get 0?
-1.
-1, right, exactly. Right? So I'm going to get 0, 1, 4. Now -1 times 1 plus 1 is 0. -1 times 4 is -4. When I add it to the 2, I get -2. And now my leading ones are the only non-zero things in their columns. So now I'm in RREF. Right?
Thank you.
No problem. So now try it with a 3 by 3, right? Try and find one of the exercises later on when there's like a 3 by 3 matrix. Write it down, write the matrix down in front of you, right? And try and row reduce it. Like, find one where I've done it in an example and I've actually worked out the row reduction. Do it on your own, make sure you can get the steps. And don't worry if yours is different than mine, because you can see like the thing that I did up here is actually different than what I did in the notes, but I still got the same answer, right? So long as you do the legal operations, then your RREF will be the same as mine. So find a 3 by 3 example and try and row reduce it and see if you get the same answer. And then if you don't get the same answer, come to office hours, drop into tutorial and be like, hey, I was trying to row reduce this, and for some reason I don't have the right answer. Can you kind of, look at my work and show me where I might have made a mistake? And then we'll be able to pinpoint exactly where the issue happened. And then we can be like, oh, here, this will help you.
Okay. Sounds good.
Okay. Okay, everyone. So I think we're after 7 now. Yeah. So thanks everyone for coming. Yeah, is there anything pressing? I guess there's an assignment due tomorrow, and then the new assignment is up, or the writing assignment rather is up. And then, yeah, other than that, have a good weekend, everyone. So I will see you later. Aziz, take off. I can tell you want to go.
No, I'm hanging out. I'm having fun.
Okay.
Anyways, have a good weekend.
Yeah. Ciao, everyone. No problem.
Bye. Have a nice weekend.
You too. See you later, everyone. Ciao.